New data just came back from the James Webb Space Telescope about the strangest visitor our solar system has ever recorded, and scientists are calling the results genuinely unlike anything ever measured on a comet before. This is not some far-off theoretical by nearly every major telescope humanity possesses, and what Webb just confirmed about its chemistry is forcing astronomers to rewrite what they thought they knew about objects that come from beyond our solar system entirely. Its name is 3I Atlas, and it is only the third interstellar object ever detected passing through our solar system, following the mysterious 1I Oumuamua in 2017 and the comet 2I Borisov in 2019. It was first spotted on July 1st of 2025 by the NASA-funded Atlas survey telescope in Rio Hurtado, Chile, immediately standing out because of its unusual hyperbolic trajectory, a path so fast and so extreme that it proved beyond doubt this object was never gravitationally bound to our Sun, moving instead on a one-way arc that could only have originated from another star system entirely. It came from somewhere else entirely, drifted alone through interstellar space for who knows how long, and briefly wandered into our cosmic neighborhood before continuing on a one-way journey back into the darkness between the stars. And 3I Atlas was different from the moment it was discovered. When first spotted, the comet was already about 410 million miles from the Sun, well within Jupiter's orbit, and moving at roughly 137,000 miles per hour, a blistering speed that only increased as the Sun's gravity pulled it inward, eventually reaching about 153,000 miles per hour at its closest approach. Astronomers also measured its rotation, finding that the nucleus completes a full spin roughly every 15 to 16 hours, a detail that helps researchers model how heat and gas distribute themselves across its surface as it swings through the inner solar system. Hubble space. Telescope observations from August of 2025 estimated its icy nucleus to be somewhere between 1,400 feet and 3.5 miles across, making it significantly larger and brighter than either of the two interstellar visitors that came before it. Unlike Oumuamua, which barely showed any comet-like activity at all, and unlike Borisov, which was relatively faint and difficult to study in detail, 3I Atlas turned out to be an extremely active, extremely bright comet, giving astronomers around the world an unprecedented opportunity to point nearly every major instrument on Earth and in space directly at it before it disappeared forever. And that is exactly what they did. Over the following year, an enormous coalition of missions turned their instruments toward this single object, including the James Webb Space Telescope, the Hubble Space Telescope, the Sphere-X Observatory, the Very Large Telescope in Chile, NASA's Parker Solar Probe, the Europa Clipper spacecraft, the Juno mission at Jupiter, and even the Lucy and Psyche spacecraft, as they happened to be passing through the outer solar system. It became one of the most thoroughly observed objects in the history of astronomy, precisely because everyone understood that once it left, it was never coming back. If watching real scientific mysteries unfold like this is your kind of thing, go ahead and like and subscribe, because the details Webb just confirmed are where this story gets genuinely strange. As 3I Atlas made its closest approach to the Sun in late October of 2025, its ancient ice, frozen since long before our own solar system even existed, began violently converting into gas, creating a bright, glowing coma around the nucleus that made detailed spectroscopy finally possible. Once the comet began pulling away from the Sun in December of 2025, astronomers seized their best opportunity yet, turning Webb's instruments directly at it to capture a detailed chemical fingerprint of exactly what this object is made of. What they found did not match anything ever recorded from a comet born inside our own solar system. The first major shock was methane. Using Webb's mid-infrared instrument, researchers detected methane gas escaping from 3I Atlas for the very first time ever recorded on an interstellar object, and the amount was staggering. The comet's methane to water ratio came back roughly 11 times higher than any previously measured object in the history of comet science, solar system, or otherwise. Scientists confirmed this was a completely natural process, purely thermal outgassing triggered by the comet's ices, sublimating as they warmed near the Sun, nothing biological or artificial about it. But the sheer scale of that ratio told researchers something important, that 3I Atlas formed and spent most of its existence in an environment far colder and far different from anything that shaped the comets native to our own solar system. Then came an even deeper clue, buried in the isotopes of hydrogen itself. Webb's NIR-SPEC instrument measured the ratio of deuterium, sometimes called heavy hydrogen, to ordinary hydrogen within the comet's water, and the number that came back was almost unbelievable. The deuterium to hydrogen ratio in 3I Atlas measured about 0.98%, more than 30 times higher than the equivalent ratio found in Earth's oceans, and more than 10 times higher than any comet ever measured from within our own solar system. separate observations using the powerful ALMA radio. Telescope array confirmed this finding independently, revealing deuterium enrichment more than 40 times what we see in Earth's oceans, and more than 30 times what's typical in solar system comets. Because higher temperatures naturally destroy this kind of deuterium enrichment over time through chemical exchange, researchers say this level of preservation could only happen if 3I Atlas formed, and then spent billions of years drifting in an extraordinarily cold environment, far colder than anything our own solar system ever experienced. The carbon told a similarly extreme story. Webb's spectroscopy revealed the ratio of ordinary carbon, 12 to the rarer isotope carbon-13 inside the comet's gas, and the numbers, ranging between roughly 141 to 191 for carbon dioxide and 123 to 172 for carbon. Monoxide exceeded typical values found anywhere in our solar system, and even exceeded values found in nearby interstellar clouds where new stars are actively forming. Because carbon-13 naturally builds up inside stars and gets distributed throughout the galaxy over enormous timescales. An unusually low concentration of it points toward extreme age. When researchers ran these isotopic signatures through models of galactic chemical evolution, the numbers suggested 3I Atlas could have formed as long as 12 billion years ago, potentially making it more than double the age of our own sun, and placing its birth during a period astronomers call cosmic noon, the era when star formation across the early universe was at its absolute peak. A completely separate study, using the European Southern Observatory's Very Large Telescope, independently confirmed this same ancient origin story, analyzing the comet's carbon and nitrogen content through the chemical signature of cyanide gas, work led by astronomer Cyril Oppitom at the University of Edinburgh. Their conclusion agreed with Webb's findings almost exactly, that 3I Atlas most likely formed in the outer regions surrounding an old low metallicity star, meaning a star that contained very few of the heavier elements that only accumulate in a galaxy over billions of years of stellar life and death. In simple terms, this comet is a genuine relic, a frozen fragment preserved from a planetary system that existed and finished forming long before our own sun ever ignited, drifting silently through the galaxy for billions of years before its path finally crossed our own. Naturally, all of this strangeness reignited a debate that has followed interstellar objects. Since Oumuamua first appeared back in 2017, could something behaving this unusually actually be artificial? Harvard astrophysicist Avi Loeb, a longtime and vocal advocate for taking that possibility seriously, publicly raised the question again in the summer of 2026, pointing specifically to the surprisingly high methane levels as something worth investigating further, even wondering aloud during a television interview whether such chemistry might hint at microbial activity, buried somewhere deep inside the object. To take that question seriously rather than dismiss it outright, the SETI Institute and the Breakthrough Listen project conducted a dedicated radio search using the Allen Telescope Array, sifting through nearly 74 million individual radio signals collected while 3I Atlas was in range. Out of that massive data set, only 211 candidate signals survived initial filtering, and every single one of them was conclusively traced back to ordinary human and satellite radio interference here on Earth, ruling out any artificial transmitter from the comet itself stronger than somewhere between 10 and 110 watts. The scientific consensus, backed by NASA, the European Space Agency, and the overwhelming majority of professional astronomers, remains firm and unambiguous. The 3I Atlas is a completely natural comet. The methane is chemistry, not biology, and certainly not technology. But natural does not mean ordinary, and that is precisely what makes this story worth paying attention to. Independent researcher Avi Loeb has continued cataloging what he describes as roughly 15 to 22 distinct anomalies observed in the comet's behavior throughout its journey, details that standard comet models built entirely from objects native to our own solar system still struggle to fully explain, including subtle non-gravitational accelerations caused by an unusual system of jets on its surface and a trajectory that carried it strikingly close to Jupiter's gravitational sphere of influence in March of 2026. None of these anomalies suggest anything artificial once properly analyzed. What they actually suggest is something arguably more profound, that our existing models of how comets behave were built almost entirely from objects that formed inside our own solar system, and that a true interstellar visitor, shaped by billions of years in a completely different corner of the galaxy, simply does not follow the same rulebook. Throughout this entire encounter, one fact never wavered. 3I Atlas never posed the slightest danger to Earth. At its absolute closest point to our planet, the comet remained roughly 170 million miles away, about 1.8 times the distance between the Earth and the Sun, an enormous, completely safe gap by any measure. It also passed behind the Sun in late October before swinging past Jupiter's orbit in March of 2026. And by the middle of this year, it had already faded to roughly 1 billion kilometers away, well beyond Jupiter, continuing to dim as it retreats permanently back into interstellar space, never to return to. Our solar system again? Likely for hundreds of millions of years, if ever. What makes 3I Atlas so significant is not that it threatens us, because it never did, but what it represents. This is only the third confirmed sample of material from outside our solar system that humanity has ever had the chance to study up close, and thanks to instruments like the James Webb Space Telescope, we did not just glimpse it, we chemically fingerprinted it in extraordinary detail before it vanished forever. The unusually high methane, the extreme deuterium enrichment, the depleted carbon-13, all of it points toward the same staggering conclusion. A frozen fragment of a planetary system that finished forming long before the Sun, the Earth, or anything on it ever existed. Researchers describe interstellar objects like this one as time capsules, physical samples carrying the chemical fingerprint of a planetary formation process that unfolded in some distant corner of the galaxy, one we would otherwise have absolutely no way of studying directly. There is also a quieter, less discussed layer to this story, the sheer scale of the international effort it took to gather all this data in the first place. Beyond the headline, grabbing instruments, missions never designed with, comet science in mind ended up playing crucial supporting roles. NASA's Swift Observatory caught the very first hint of water escaping the comet through the faint ultraviolet glow of hydroxyl gas, detecting an outgassing rate of roughly 40 kilograms of water per second, even while the object was still unusually far from the Sun, much farther out than where most comets typically begin actively venting material. The Parker Solar Probe, normally busy studying the Sun's outer atmosphere, spent nearly 3 weeks in October and November of 2025 quietly snapping images of the comet as it passed nearby. Even the Europa Clipper mission, on its way to study one of Jupiter's icy moons, paused to capture 7 straight hours of ultraviolet observations from over 100 million miles away. None of these missions were built for this. Scientists simply recognized a once-in-a-generation opportunity and repurposed nearly every capable instrument they had access to, coordinating an unprecedented improvised observation campaign across more than a dozen separate spacecraft and observatories, all racing against the clock before their target faded permanently out of reach. That urgency mattered, because 3I Atlas is not coming back, and objects like it are exceptionally rare. Only 2 other confirmed interstellar visitors have ever been detected before this one, meaning that in the entire recorded history of astronomy, humanity has only caught 3 genuine glimpses of material from beyond our own solar system, and this was by far the most detailed look we have ever gotten. Every single measurement collected, from the composition of its coma to the subtle wobble in its trajectory, has already been published as open data through NASA's planetary data system, ensuring that researchers for decades to come will still be mining fresh insights from this single, fleeting encounter long after the comet itself has faded from view entirely. Scientists expect the Vera Rubin Observatory, which had already serendipitously photographed 3I Atlas during its own commissioning phase before the object was even officially discovered, to uncover many more interstellar visitors once its full sky survey begins in earnest, potentially transforming what was once a once-in-a-decade event into a regular occurrence for astronomers over the coming years. As new survey telescopes like the Vera Rubin Observatory come fully online in the coming years, scientists expect to start finding interstellar visitors like this one far more often, and each discovery brings us one-step worlds, born around other stars entirely, have quietly drifted through the darkness of our own galactic backyard.